Okay, welcome back. This is Mr. Laiche, Portland Math Tutor. Today we are tackling the SAT practice test, version 8. We're taking a look at sections 3 and 4, the math sections. Alright, let's go. So we're going to start with section 3, which is the no calculator section. And here are here's your formula sheet. You can always come back and take a look at that throughout the test. Okay, so number 1. 3x plus x plus x plus x minus 3 minus 2 equals 7 plus x plus x. Okay, what's the value of x? Well, we're just going to combine like terms. On the left, we see that we have, so we got 1, 2, 3, 4, 5, 6 x's. Okay, so that's going to be 6x. And then we can see that we have negative 3 and negative 2. That's going to be negative 5. And on the right, it's a little bit simpler. We have 1x, 2x. It's going to be 2x, and then we just have that 7. Okay. We have that 7. So it's just going to be plus 7. Okay, so I'm going to combine like terms, minus 2x minus 2x, and I'm going to get 4x minus 5 equals 7. Add 5 to both sides. You get 4x equals 12. And then, of course, we're going to divide by 4. We get x equals 3. X equals 3 is our answer. Number 2. The graph above shows the distance traveled d in feet by a product on a conveyor belt in minutes after the product is placed on the belt. Which of the following equations correctly relates d and m? Well, this comes up a lot on the SAT. These are equations in slope-intercept form. So we just need to figure out the slope and the y-intercept. Well, we can see that the y-intercept, pretty clear that the y-intercept is 0. Okay, so off the bat we can eliminate x, c and d because they both have an intercept of 2. And now we just need to figure out the slope to determine if it's a or b. Well, the slope is rise over run, and it appears that the slope for this graph is goes up 2 feet every 1 minute. So we would say that the slope is 2, and that would correlate with or correspond to A for our solution. 3. The formula below is often used by project managers to compute E, the estimated time to complete a job, where O is the shortest completion time, P is the largest completion time, and M is the most likely completion time. Which of the following correctly gives P in terms of E, O, and M? Okay, you're gonna almost guaranteed you're gonna get a problem like this on your actual SAT. You're just solving the equation for a given variable, in this case P. So we're just going to take the original equation, O plus 4m plus P over 6. I'm going to multiply both sides by 6. I'm going to get 6e equals O plus 4m plus P. Okay, well, I need to subtract O. It's not 0, that's O. And I need to subtract 4m from both sides. So those will cancel off on the right side. And I'm going to subtract it from the the left side as well, and minus 4m. Okay, so I'm going to get 6e minus o minus 4m equals p. Alright, and it looks like that corresponds to A for our solution. Number 4. In the figure above, RT equals TU. What is the value of x? Alright, we'll just start off with RT and TU are equal. Okay, so that's an isosceles triangle. That means that the base angles are going to be congruent, and I'm going to call that angle A. All right, so therefore 2A plus 114 must equal 180. Okay, the sum of the interior angles of degrees of a triangle add up to 180. I'm going to subtract 114 from both sides. 2a equals, it's going to be 66, and divide by 2. So angle U and angle R are both going to be 33 degrees. Alright, well, likewise, I know that I can use that, this angle, and this angle right here, I'll call that B, are going to add up to 180 as well. So I know that 31 plus A, which is 33, plus B equal 180. Okay, so that's 64 plus B equals 180. Okay, so then I see that angle B equals 180 minus 64 is going to be 117. Did I get that? No, I didn't get that right. Let's see. Not 117, 116. Okay. Well, I know that x and b sum to 180. Therefore, I know that x has to be 64. So C is my solution. 5. The width of a rectangular dance floor in W feet is W feet. The length of the floor is 6 feet longer than its width. Okay, so I'm just gonna like to get a little sketch going as soon as possible. We know that the width is W and the length is W plus 6. Which of the following expressions expresses the perimeter in feet of the dance floor in terms of W? Okay, so I know that I've got W on that side, and I know this is going to be W plus 6. So we can just add up these sides here. I'm going to have 2W and 2W, that's 4W. And then I'm going to have 6 and 6, which is 12. So my answer is going to be 4W plus 12. Number 6. Y is greater than 2x minus 1, and 2x is greater than 5. Which of the following consists of the y coordinates of all the points that satisfy the system of inequalities above? Okay. Alright, well, let's see. We've got these are almost the same. Sorry, these expressions on this and this. Alright, they're almost the same. Let's write this again. Y is greater than 2x minus 1, and 2x is greater than 5. Well, if we just subtract 1 from the left side and 1 from the right side, we would see that y is greater than 5 minus 1, which is 4. So y is greater than 4 would be the solution to this. Number 7. What is the solution set of the equation above? Okay. So if we want to solve a radical function, we need to isolate the radical. So let's see, it's going to be 2x plus 6 plus 4 equals x plus 3. So I'm going to subtract 4 from both sides. We will get square root of 2x plus 6 equals x minus 1. Alright, now I'm going to square both sides. On the left, I'm just going to have, well, 2x plus 6. And on the right, I'm going to expand that, so it's going to be x squared minus 2x plus 1. And this is a quadratic, so to solve a quadratic, we set it equal to 0. I'm just going to subtract 2x and subtract 6 from both sides. We get 0 equals x squared minus 4x minus 5. Alright, well, our a value is 1, so we're looking for two numbers that multiply to c and add to b. Okay. Well, that looks like it's gonna be negative 5 and positive 1. Okay, so 0 equals x minus 5, x plus 1. Alright, so these are going to be, this first factor corresponds to a solution of x equals 5. The second factor corresponds to a solution of x equals negative 1. Alright, so now we need to, since we solved a radical with using a quadratic, we're going to need to check our solutions here. So let's put 5 into the equation and see what we get. So we're going to have, if we put in a 5, we'd have 2 times 5 is 10. 2 times 5 is 10 plus 6 square root plus 4 equals, well, 5 plus 3 is 8. Okay, the square root of, well, 10 plus 6, that's 16. Square root of 16 is 4 plus 4 equals 8. Yes, 5 works. 5 works. Let's check negative 1. If we put negative 1 in, we're going to have 2 times negative 1 is negative 2 plus 6 plus 4 equals, well, negative 1 plus 3, that's going to be 2. Alright, so then inside the square root we have square root of 4 plus 4 equals 2. No, that's going to be 2 plus 4 is 6. 6 does not equal 2. So negative 1 is not a solution. So the only solution that works for this is going to be 5. Our answer is B. Number 8. Okay, we get a cubic and a quadratic. Which of the following expressions is equivalent to f of x over g of x for x greater than 3? So f of x over g of x. So that is going to be, now let's just divide. Okay, so actually we might be able to factor. I'm just going to write this out here. I'm going to see that the top expression f of x has a common factor of x. We'll have x squared minus 9. Perfect. Now I recognize that's a difference of squares. And the denominator, well, the denominator, we want two numbers that multiply to negative 3 and add to negative 2. Well, those are going to be negative 3 and positive 1. Yeah? And I can see that I'm going to simplify the top one more step. This difference of squares right here can factor as such. So difference of squares is going to be the square root of the first minus square root of the second times square root of the first plus square root of the second, all over x minus 3 times x plus 1. So the x minus 3's cancel out, and we're just left with x times x plus 3 over x plus 1. And that looks like D is our solution. 5 plus, oops, number 9, we have an equation of a circle here. In the xy plane, the graph of the equation above is a circle. Point P is on the circle and has coordinates 10, negative 5. If PQ is a diameter of the circle, what are the coordinates of Q? Okay, well, let's think about this. We know that the circle has a center at 6, negative 5. So let's say right there, 6, negative 5. Because the equation for a circle, you should definitely know this. It's going to come up on the test. Y minus k squared equals r squared. Okay. And we know that 10, negative 5, oh, well, that's going to be right here. 10, negative 5 is on the circumference. Well, that's on the same, it's horizontal with the center. Well, we know that 16 equals the radius squared, so 4 equals the radius. And that makes sense. 6 plus 4 is 10. Well, then 6 minus 4 should be the other point. A point on the opposite side of the circle, which should be a 2, negative 5. Okay, and that is our first solution. 10. A group of 220 people went on an overnight camping trip, taking 60 tents with them. Some of the tents held 2 people each, and the rest held 4 people each. Okay, so that's going to be significant. So we got, there's some of them, the two-person, and then we have some 4-person tents. Assuming all tents were filled to capacity, and every person got to sleep in a tent, exactly how many of the tents were 2-person tents? Okay, so let's get some variables out here. I'm going to use T for the 2-person tents and F for the 4-person tents. Okay. We know that the total number of tents that they brought was 60. Okay, so we can say that number of tents T plus the number of tents F equals 60. And we know that the total number of people that came on the trip was 202. Well, that's going to be made up of people that slept in a 2-person tent and people that slept in a 4-person tent. So each 2-person tent held 2 people, plus each 4-person tent held 4 people. Okay, so we have a system of equations here. I am going to, we want to know how many people were in the 2-person tents. So we need to figure out the number of 2-person tents. That means that I want to eliminate the 4-person tents. So that's just going to save me a little bit of time. That way when I get my answer to this system, I don't have to plug anything back in to find the other variable. Alright, so if I'm eliminating the F, the 4-person tents, I see that this first equation, if I subtract T from both sides, I'll get 60 minus T. Oops. 60 minus T equals F. Okay, well I can substitute that into the second equation here. Alright, so I've got 202 equals 2t plus 4 times 60 minus t. Alright, so 200, I'm just going to distribute here, plus 240 minus 4t. Alright, I'm going to subtract 240 from both sides, and I'm going to combine like terms. So 202 minus 240, well, I know it's going to be negative, so I'm just finding the difference, and that's going to be 38. It's going to be negative 38. And I'll combine like terms on the right. That's just going to be negative 2t. Alright, divided by negative 2, I see that that's going to be, what's that, 19 equals t. Well, 19, how many of the tenths were two-person tenths? 19. Yes, that's our answer. Perfect. C. 11. Which of the following could be the equation of the graph above? Alright, well, just right off the bat, we can look at this as, we can at least figure out the degree. We've got a 1, 2, 3, 4, looks like a 4th degree polynomial, and we've got intercepts at -3, 0, and 2. Okay, so that's going to be, we've got x plus 3. That's accounts for the -3. And then I've got, I'm going to put the x in front, just x minus 0, which is just x. And then this intercept 2 is going to be x minus 2. I know that this intercept at the origin is a bounce, so it's going to be 2nd degree. And this all adds up to a 4th degree polynomial. And it looks like answer B, it fits the bill. Excellent. 12. 2a on b equals 1/2. What is the value of b over a? Okay. So let's get b and a isolated. Let's see how to do that. So we got 2a over b equals 1/2. Alright, well, it looks like I need to divide both sides by 2. So if I divide both sides by 2, I'll get, these 2's will cancel out. I'll have a on b equals, well, half of a half is a 4th. I don't want a on b, I want b on a. Okay, so I can, one property is that I can, of a proportion, is that I can take the reciprocal of both sides. So if I take the reciprocal of the left, it's kind of like raising it to the negative power of -1. I get b over a on the left, and on the right I just get, well, it's just 4. So my answer is D. 13. Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that the oil and gas production decreased at a constant rate, that's key right there, constant rate, that means we're talking about a linear relationship. Which of the following linear functions f best models the production in millions of barrels, t years after 2000? Okay, so we need two things if we're going to write a linear equation. We'll need the slope as well as the y-intercept, or the starting value. Okay, so the slope, or the rate of change, is just the change in the output, which is barrels, divided by the change in the input, which is years. Okay, so we're going from 4 million barrels to 1.9 million barrels, and we're going from 2000, which is 0 years, to 13 years. Of course, you can flip this around. This would be the same as 1.9 barrels minus 4 over 13 minus 0. Okay, so what we're going to get here is 4 minus 1.9 is 2.1 over negative 13, so I'm just going to stick the negative on top. So our slope is negative 2.1 on 13. Now it looks like none of the slopes here have a decimal, so I'm going to multiply the top and the bottom by 10. I'll get negative 21 on 130. Okay, so we've got our rate of change, and in fact we already have our y-intercept, because the y-intercept is just the number of barrels in the year 2000, which was 4. Okay, so if I write the equation, it's going to be f of t, the barrels produced, is going to equal negative 21 on 130 times years past 2000 plus 4, the starting value. And that is answer C. 14. Y equals x squared plus 3x minus 7. Y minus 5x plus 8 equals 0. How many solutions are there to the system of equations above? Okay, so we're going to be using the discriminant. Discriminant comes out of the quadratic formula. The discriminant, let's get a pen here. Okay. Discriminant is that piece underneath the radical, b squared minus 4ac. And we know that if that is greater than 0, then there are 2 solutions. If that is equal to 0, there is 1 solution. And if that is less than 0, there are no real solutions. Okay, so we're going to take our system here, and we need to I'm going to substitute in. It looks like I know what y equals here, and I can just substitute that into my equation down here. So what I'm going to get is x squared plus 3x minus 7, and then minus 5x plus 8 equals 0. All right, if I combine like terms, I'm going to get x squared, and then 3x minus 5x, that's going to be negative 2x, and then negative 7 plus 8, that's going to be plus 1. Okay. Now, let's see. Well, I can see right away, I don't even need to use the discriminant. I know I can factor this as x minus 1 equals 0. And if that's the case, then there's really only going to be 1 solution. So C would be our answer. However, if we decide to go through, if we couldn't factor it quite this easily, we could go through and figure out what the determinant was, or discriminant. So let's take B. B is negative 2. A equals 1, and C equals also 1. So the discriminant equals b squared, so that's going to be 4 minus 4 times 1 times 1 is just 1, and that's going to be 0. So yeah, we are going to be having just 1 solution. 15. G of x equals 2x minus 1. H of x equals 1 minus g of x. The functions g and h are defined above. What is the value of h of 0? Okay. H of 0. Okay, so this is just a little function notation. h of 0 equals 1 minus, well, g of x is just 2x minus 1. So that's going to be 2 times 0, because I have to put 0 in for my x, minus 1. Okay, so that's going to be 1 minus, well, this is going to cancel out, and I just have negative 1. Minus negative 1 is plus 1, so 2. D is our answer. 16. X squared plus x minus 12 equals 0. If a is a solution to the equation above and a is greater than 0, what is the value of a? Okay, so we need to solve this quadratic. It's already in standard form, and a equals 1. That's great. That means that we can factor this by just looking for two numbers that multiply to c and add to b. All right, well, c is negative 12. C is negative 12. And we have 1, 12. We have 2, 6, and 3, 4. Those are the factors. Given that one of them has to be negative because the product is negative, which pair can add up to positive 1? Let's see, that's got to be this one. 4 and negative 3, they add up to positive 1. So in factored form, it's going to be x minus 3, x plus 4 equals 0. Well, the solution that corresponds to the first factor here is going to be 3, because that would make that factor equal 0, and the product would be 0. And then the solution that corresponds to the second factor would be negative 4, because that would make that factor equal 0, resulting in the product of 0. So we know a is greater than 0, x equals 3, or a equals 3 would be our solution. Okay? Number 17, the sum of negative 2x squared plus x plus 31 and 3x squared plus 7x minus 8 can be written in the form ax squared plus bx plus c, where a, b, and c are constants. What's the value of a, b, and c? Okay, so if we add these two equations together, we're just adding the squared terms. That's just going to be x squared. Adding the linear terms, that's going to be 8x. And then adding the constants, that's going to be 31 minus 8. That's going to be positive 23. All right, so we've got our a in front. That's a 1. We've got our b on the linear term. That's an 8. And we have our c as a constant. Okay, so 1, 8, and 23. If we add those all together, we are going to get 9. 1 plus 8 is 9. 9 plus 23 is 32. 18. All right, looks like we have a system. If x, y satisfies the system of equations above, what is the value of y? All right, so if we are solving for y, it would be nice to eliminate the x's, and it looks like if I just add these two equations together, because we have additive inverse coefficients on the x terms, I think that'll suffice. That'll eliminate our x's, which we're not really concerned with. We're concerned with the y's. So if I add these two equations together, my x terms are going to cancel out, and then I've got 4y, and then this is going to be 6. Okay, so divide both sides by 4. Y equals, and I guess I'll reduce that. That'll be 3 halves. So y equals 3 halves. 19. A startup company opened with 8 employees. The company's growth plan assumes that 2 new employees will be hired each quarter, every 3 months, for the first 5 years. If an equation is written in the form y equals ax plus b to represent the number of employees y employed by the company x quarters after the company opened, what's the value of b? All right. So this is in the form of y equals mx plus b, and that constant is the starting value. That constant is the starting value, the y-intercept. Well, we already know the y-intercept. They told us in the first sentence here. Startup company opened with 8 employees. Okay? So, it doesn't really matter anything else. Our solution here is 8. 20. Note, figure not drawn to scale. Okay. In the circle above, point A is the center, and the length of arc BC is 2/5 of the circumference of the circle. What is the value of x? So we have a arc here, and BC, and that's 2/5 of the circle. Well, the arc and the central angle are proportional. Okay, so if the arc was equal to the circumference, so in which case it'd be 1/1 of the circumference, then the arc would be 360. Since we have 2/5, it's going to be the central angle there will be, there we go, will be 2/5 of, are we in degrees? Yeah, I assume we're in degrees. Yep. It would be 2/5 of 360. Okay. So I'm just going to reduce here, divide the top and the bottom by 5. I'm going to get a 72. So 2 times 72, 144. 144 is the value of x. 144 degrees. Okay, section 4, the calculator section. Here is the reference chart, your formulas for volume and area. Come back to that if needed. Number 1, 1 pound of grapes costs $2. At this rate, how many dollars will C pounds of grapes cost? Okay, well, it's just 1 pound of grapes costs $2. So every pound of grapes is going to cost an extra $2. So it's going to be 2 times the number of pounds of grapes. Number 2, Tracy collects, sells, and trades figurines, and she tracks the number of figurines in her collection on the graph below. On what interval did the number of figurines decrease the fastest? Okay, so if we're talking about decrease, then we're looking where did the value of the function go down, and decreasing the fastest would be where the slope is the most negative, or the steepest negative slope. And just eyeballing it, it looks like this portion is the steepest slope. That's from 3 to 4. So let's look at our answers. Between 1 and 2, no. 2 and 3, yes, between 3 and 4. So C is the answer. 3. In a random sample of 200 cars of a particular model, 3 have a manufacturing defect. At this rate, how many of 10,000 cars of the same model will have a manufacturing defect? Okay, so that's 3 out of 200 have a defect. So we want to know How many have a defect out of 10,000? Okay, so to solve this, we just need to multiply both sides by 10,000. Do that on the left. I'll get 30,000 over 200 equals x. Cancel out some of these zeros. 300 divided by 2 is 150. So 150 is the expected number of models with a defect, or cars with a defect. 4. Dimensions of iris petals. The scatter plot above shows data collected on the lengths and widths of iris setosa petals. A line of best fit for the data is also shown. Based on the line of best fit, if the width of an iris setosa petal is 19 millimeters, what is the predicted length in millimeters for the petal? So it's saying that the width is 19 millimeters. Okay, so that's going to be over here somewhere. Yeah, it's going to be somewhere up here, and we want to know the length. Well, we've got an equation for the line of best fit, so all we need to do is just plug in our input, which is 19. So y equals 1.67 times 19 plus 1.1. Okay, so since this is the calculator section, I'm just going to pull up my calculator real quick on this. 1.67 times 19, that's 31.73 plus 21.1, okay, equals the output. Well, that's going to be 52.83. That is our answer. C would be our answer. Number 5. Let's see. In the figure above, lines L and M are parallel. Y equals 20, Z equals 60. What is the value of X? Alright, well, parallel lines, we should be thinking about our properties of transversals, thinking back to geometry. And I can see that I've got this angle Y and this angle here in the top triangle are corresponding, so I know that this angle equals Y. Okay, and I also know that that X plus Y plus Z needs to equal 180. Alright, well, we got X, we don't know X, but we know Y is 20 and Z is 60 equals 180. So that looks like 80 on the left. I'm going to subtract 80 from both sides. I'll get X equals 100. So B is our answer. 6. 2 types of tickets were sold for a concert held at an amphitheater. Tickets to sit on a bench during the concert cost $75. Oh boy, lucky. Sit on a bench. Okay. So the bench was $75. And tickets to sit on the lawn during the concert were $40. Okay, so lawn was $40. Okay. Organizers of the concert announced that 350 tickets had been sold. So 300 tickets had been sold, and $19,250 had been raised through ticket sales alone. Which of the following systems of equations could be used to find the number of tickets for bench seats and number of lawn seats? Okay, so let's start out with, well, we know 350, so 350 is the sum of the two, and it looks like they're using B and L. So B plus L should equal 350. Okay, I'm going to eliminate that one. That doesn't fit the bill. And we know that the total revenue is the sum of the revenue for bench tickets and lawn tickets. So bench tickets were $75 times the number of bench tickets, plus the lawn tickets were $40 times the number of lawn tickets, and we know that that equals 19,250. Okay, so there's our system of equations, and we just need to figure out which ones work. Well, the first one is they're not adding the two sales of the money they got from bench and the money they got from the lawn tickets. They're multiplying. That's not it. The second one, $40 for the bench. No, it was $40 for the lawn. That's not it. And the last one, 75 for bench, 40 for lawn. That looks like our solution, D. Number 7. In the xy plane, the graph of which of the following equations is a line with a slope of 3? Okay, so I keep saying this, but it's really true. If you feel comfortable with this slope-intercept form, you're gonna do much better on this test. All right. So we know that the slope is m, and we want to equate one of these equations with a slope of 2, or sorry, slope of 3. It's kind of just a freebie. It gives it to you right there. C. 8. Alright, x plus 1 equals 2 on x plus 1. In the equation above, which of the following is a possible value of x plus 1? Okay, so to solve this, I am going to 2 on x plus 1. I'm going to multiply both sides by x plus 1. If I do that, I'll have x plus 1 times x plus 1 equals 2. I'll expand the right. I'll get x squared plus, that's 2x plus 1 equals 2. And this is a quadratic. To solve a quadratic, I need to set it equal to 0. So x squared plus 2x minus 1 equals 0. I see that there are a is 1, but there are not any two numbers that multiply to negative 1 and add to 2. So I'm going to have to use the quadratic formula. Quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. So in this case, a equals 1, b equals 2, and c equals negative 1. Okay, so then I'm going to have x equals, well, negative 2, right? Negative b is negative 2 plus minus the square root of b squared, that's 4, minus 4 times a times c. Well, a times c is negative 1. So negative 4 times negative 1 is going to be positive 4. All over 2a, which is going to be 2. Okay, I'm going to go this direction. I'll get x equals negative 2, and that's going to be square root of 8. To simplify that, I would write it as a square root of 4 times the square root of 2. That would be the square root of 8 over 2. Okay. And we have, well, the square root of 4 is just 2, so it would be negative 2 plus minus 2 root 2 over 2. Okay, so I am going to, actually I'm going to copy that. See if we can bring it up here. Okay. And cordon this off a little bit. Alright, so I can divide each term in the numerator by 2 and the denominator by 2. So I'm going to get x equals negative 2 plus minus square root of 2. Alright, so if we have x plus 1, right? We would be adding 1 to this. Let's see, so we've got, oh, made a mistake. That would be -1 plus or minus the square root of 2. Okay, so that's our solution. And if we think about the positive, it'd be -1 plus the square root of 2. All right, and if we add 1 to that, it would just be the square root of 2. And if we think about the negative, it'd be -1 minus the square root of 2. Well, plus 1 would just be negative square root of 2. So B is our solution. Okay, number 9. What we have here, the glass pictured above can hold a maximum volume of 473 cubic centimeters, which is approximately 16 fluid ounces. What is the value of K in centimeters? Okay, so we know the volume. We know the volume formula, and we know the volume in centimeters, so, or cubic centimeters. 473 equals 7 pi K cubed on 48. Alright, so I'm gonna multiply by the reciprocal of 7 pi on 48. It's gonna be 48 on 7 pi times 473 equals K cubed. Okay, well, I'm going to use my calculator for this. I get 48 times 473, and then I'm going to, that's 22704 divided by 7 pi equals K cubed. Okay, so then I'm going to divide by 7 pi. Got to use parentheses, okay? And I get that 1032.42 equals K cubed. Alright, well, I just need to take the cube root of both sides. Maybe your calculator doesn't do arbitrary roots, so one thing you can do is raise both sides to the 1/3 power. So I'm just going to do 1032.42 raised to the 1/3 equals K. Okay, raised to the 1/3. Okay, and I get that K approximately equals 10.106 approximately equals K. Alright, and it looks like D would be our solution. Number 10. Alright, this is the same setup as 9. Okay, water pours into the glass slowly and at a constant rate. Which of the following graphs best illustrates the height of the water level in the glass as it fills? So just just looking at this right away, I would be tempted to pick A, because this has a constant. This would be the cup being filled at a constant rate. The elevation is increasing at a constant rate. However, the cup is tapered at the bottom. So this graph would be true if the glass were had straight sides. Okay, however, that's not the case. All right. The second one shows us that the water level is increasing slowly at first, and then speeds up later on. Well, there's less volume on each level at the bottom, as it goes up, the volume of each layer gets more greater and greater. So it's going to take more time to fill up as the water level increases. So B would not be accurate. C looks like it's probably going to be our answer here. The water level increases rapidly at first because the cup is small at the bottom, and then as it starts to fill, the width of the cup gets larger, and it takes more time to fill the cup as the water level rises. On the bottom, this is saying that the water level does not change at all. Well, that's not true. Number 11, same situation. Jenny has a pitcher that contains 1 gallon of water. How many times could Jenny completely fill the glass with 1 gallon of water? Okay, well there's 16. It says that there are 16. This is approximately 16 ounces, right? So we just take it's 1 gallon is 128 ounces divided by 16. So I'm just gonna, let's see, divide by 2. We get 64 over 8. Okay, that's 8 glasses. Roberto is an insurance agent who sells 2 types of policies, a $50,000 policy and a $100,000 policy. Last month, his goal was to sell at least 57 insurance policies. While he did not meet his goal, the total value of the policies he sold was over $3 million. Which of the following systems of inequalities describes X, the possible number of $50,000 policies? Okay, I'm going to highlight that. So X is $50,000 policies, and Y is $100,000 policies. Okay, all right. So we know that he sold at least. His goal is to sell at least 57. Now, he did not meet his goal. So if he did not get 57, we know that that is going to be greater than the number of $50,000 policies and the number of $100,000 policies. Okay, so right off the bat, I am going to eliminate B, and I'm going to eliminate D. Those don't satisfy the first inequality. All right, the second inequality is going to be the sum of the $50,000 policy is going to be 50,000 times X plus the sum of the $100,000 policies, which is 100,000 Y. We know that the total value of the policies was over 3 million, so that's greater than 3 million. Okay, and it looks like C is our solution because in A it's less than. Okay, C. 13. A to the negative 1/2 equals X, where A is greater than 0. What is A in terms of X? All right, so if we want to get rid of that exponent, we need to raise it to something that would make it equal 1. Well, we need to raise it to, well, that would be negative 2 over 1, right? And then I got to do the same to the other side. So negative 2 over 1 is just negative 2. Okay? And we know that negative exponent, you bring it across the fraction bar, so that's going to be x over, or 1 over x squared. That's C. 14. Which of the following is a value of x for which the expression negative 3 over x squared plus 3x minus 10 is undefined? Well, undefined, that's the key. Undefined means that the denominator equals 0. So what value of x makes the denominator equal 0? Okay, so let's factor. Well, a is 1. This came up several times, right? A is 1, so we're looking for a number that two numbers that multiply to c and add to b. Okay, so that's going to be negative 10 is c. Well, the factors of 10 are 1, 10, 2, and 5. Given that one of them needs to be negative because they multiply to a negative, it looks like 2 and 5 with a negative 2. So we're going to have x minus 2, x plus 5 equals 0. Okay, so this factor is going to correspond to x equals 2 as a solution, and then this factor is going to correspond to x equals negative 5 as a solution. Okay, and where do we see a solution in our list here? We see it at D, 2. Number 15. A granite block in the shape of a right rectangular prism has dimensions 30 centimeters by 40 centimeters by 50 centimeters. The block has a density of 2.8 grams per cubic centimeter. What is the mass of the block in grams? Okay, so we also get a little bit of information here. We're given that the density is mass per unit volume. So density equals mass per volume. Okay, so let's do some calculations here. We have a rectangular prism, and we know that it is 30 by 50 by 40. So the volume is going to be the area of one of the faces times the depth. So we're going to have 30 times 40 times 50. Okay, well, 30 times 40, that's going to be 1200. And then 1200 times 50, 12 times 5 is 60. And then we're going to have 1200 has 2 zeros and 50 has 1, so 1, 2, 3 more zeros. So the volume for this prism is 60,000 cubic centimeters. Okay, and we know the density is 2.8 grams per cubic centimeter. So we know that the mass is going to be the density times the volume. So we have 2.8 times 60,000. Let me do that on my calculator here. So we have 60,000 times 2.8. That is going to be 168,000 grams. Okay, 168,000 grams, and that would be D. All right, 16. Number of adults contracting colds. The table shows the results of a research study that investigated the therapeutic value of vitamin C in preventing colds. A random sample of 300 adults received either a vitamin C pill or a sugar pill each during a 2-week period. And the adults reported whether they contracted a cold during that time period. What proportion of adults who received a sugar pill reported contracting a cold? Alright, so we're only looking at a subsection of the sample. We're only looking at adults adults who received a sugar pill. Okay, so then we're only looking in this row of the table, and of that, who reported contracting a cold? Well, 33 reported contracting a cold, so it's going to be 33 out of, well, the total that received the sugar pill are 150 out of 150. Okay, well, I know I can divide both those by 3, so 33 divided by 3 is 11. 150 divided by 3 is 50. So 11 50ths. That'd be B. 17. Ages of 20 students enrolled in a college class. The table above shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode of the ages? Okay. So the ages are already listed out in order from least to greatest. So I'm going to, I think I want to calculate the median first. So let's see. We've got 20 students, and we need to count in. We're going to be, the middle of that is going to be, the median, sorry, it's going to be 20 plus 1 divided by 2. I'm going to find the average. Okay, and that's going to be 21 divided by 2 is 11.5. Okay, so the median is going to fall in between the 11th and the 12th data point. Okay, so let's count in that many. Let's find the 11th and the 12th. So we have 1, 2, 3, 4, 5, 6, and then we have 7, 8, 9, 10, 11. Okay, so the 11.5 is going to fall in between this mark, the 19 and 20 age range. So the median for this is going to be 19.5. The mode, well, the mode is pretty easy. It's on the, we can look at the frequency table. We see that 18 is the mode. That happens the most often. And the mean is going to be the average. Well, the average is the sum divided by how many there are, and there are 20. Okay, so let's pull up a calculator here. So we're going to have 18 times 6. There are 6 in that category. So 18 times 6 plus 19 times 5. 19 times 5 plus 20 times 4 plus 21 times 2. 21 times 2 plus 22 plus 23 plus 30. Okay, that's a total of 400. 400. And we know there are 20 individuals, or 20 students, so we see that the mean is going to be 400 divided by 20. Well, that's just 20. So we see that the greatest is, or the smallest is going to be the mode, followed by the median, and then followed by the mean. That's going to be A. Mode, median, mean. 18. The figure below shows the relationship between the percent of leaf litter mass remaining after decomposing for 3 years and the mean annual temperature in degrees Celsius in 18 forests in Canada. a line of best fit is also shown. Okay. So as the temperature goes up, the mass, the leaf litter mass remaining goes down. All right. A particular forest in Canada whose data is not included in the figure had a mean annual temperature of -2 degrees Celsius. Based on the line of best fit, which of the following is closest to the predicted percent of leaf litter mass remaining in this particular forest after decomposing for 3 years? Okay, so we want to find on the x-axis, we want to find -2 degrees Celsius, and that's going to be approximately right about there. And we go straight up to our graph, and we'll see that, oh, it's going to be about 70%. Approximately 70% will be remaining. 19. The range of the polynomial function f is the set of real numbers less than or equal to 4 if the zeros of f are -3 and 1. Which of the following could be the graph of f of y equals f of x? Okay, so we have 2 zeros. Okay, 2 zeros. Okay, I can right away I can rule out D because there are 3 zeros in that one, and we know that y, the output, the value of the function, has to be less than or equal to 4. So we're going to rule out C because this is greater than 4 going up. Yeah. All right. So take a look at A and B. Well, these are both max out at 4. So they both have a maximum value of 4. And so we need to look at the x-intercepts. The x-intercepts are -3 and 1. Well, that would work for A, but it would not work for B. B, we have an intercept at -1 and 3. So B is not our solution. A for 19. 20. The average annual energy cost for a certain home is $4,334. The homeowner plans to spend $25,000 to install a geothermal heating system. The homeowner estimates that the average annual energy cost will then be $2,712. Which of the following inequalities can be solved to find T, the number of years after installation at which the total amount of energy cost savings will exceed the initial cost? Okay, so the initial cost is let's see, the initial cost is $25,000. Okay, and we want to exceed that, so we're going to be greater than 25,000, and the homeowner estimates that we have an annual, so our annual energy consumption is 4,334, and after the installation it will be 2,714. So the amount saved would be the difference in those two. So we'd have the difference in those would be 4,334 minus the new cost, the new expense, 2,712, and that's how much you save per year, right? And then we want to multiply that times the number of years to figure out when will that savings exceed 25,000. All right, well, it looks like A has the inequality backwards, but B B is what we were looking for. Excellent. Number 21. All right. Between 1985 and 2003, data were collected every 3 years on the amount of plastic produced annually in the United States in billions of pounds. The graph below shows the data and a line of best fit. The equation of the line of best fit is y equals 3.39x plus 46.89, where x is the number of years since 1985, and y is the amount of plastic produced annually in billions of pounds. Okay. So, that means that every year, so for instance, in 1985, United States must have produced this much, this many billion pounds of plastic, which, since we have our equation in slope-intercept form, we can see that in 1985 we produced 46.89 billion pounds of plastic. We can keep going along this graph, and we see that in 3 years after 1985, we produced a little under 60 billion pounds of plastic. All right. So let's see. Which of the following is the best interpretation of 3.9 in the context of the problem? Okay. So 3.9, y equals mx plus b. 3.9 is the rate of change, and since this is billions of pounds of plastic produced per year, what this is telling us is that every year we increase the amount of plastic we produce. We increase the amount of plastic we produce by 3.39 billion pounds. All right, let's look at these answers. A, the amount of plastic in billions of pounds produced in the United States during the year 1985. No, clearly not. We produced that much, which actually happens to be 46.89 billion pounds in 1 year. All right, B, the number of years it took the United States to produce 1 billion pounds of plastic. Again, no, that doesn't fit with the graph. All right, C, the average annual plastic production in billions of pounds in the United States from 1985 to 2003. Well, clearly that's not the case, because the plastic production in 1985 was 46.89 billion, and the plastic production increased every it continued to increase, right, to over in 18 years after 1985, the production is over 100 billion pounds of plastic per year. So 3.9 is not the average production of plastic. D, the average annual increase in billions of pounds of plastic produced per year in the United States from 85 to 2003. Yes, right? That's the average increase. That's the slope of the graph. Rise over run, right? And since we're talking, this graph is showing us the annual average production of plastic. D would be our solution. Number 22. Okay, this is the same setup as 21. Question is, which of the following is closest to the percent increase in billions of pounds of plastic produced in the United States from 2000 to 2003? Well, 2000, that's 15 years after 1985, and then 2003 must be 18 years after 1985. So let's look at the graph. Let's just get an idea of what we're dealing with here. 15 would be right here. So that would be right there. 18 right there. All right, straight up from the 18. Okay, so this looks like maybe it's just slightly under. That looks like it's 99 in 2000, and then in 2000, or sorry, yeah, 2003, it looks like maybe it's 108, 108. Okay, so that would be an increase of 9. That would be an increase of 9 billion pounds of plastic. Well, we're saying relative to 2000. Well, 2000 was approximately 99 billion. Okay, so then 9 divided by 99, that's going to be, well, 1. That's 1/11th. 1/11th. Okay, as a percent, that's going to be pretty darn close to 1/10th. And since there's such a big gap in between these values, 10 and 40%, it clearly did not increase by 40%. 40% increase would be, go from 100 to 140. Yeah, that'd be up here somewhere. That did not increase that fast. So 10% is our solution. 23. M equals 1800 times 1.02 to the t. The equation above models the number of members M of a gym t years after the gym opens. Of the following, which equation models the number of members of the gym Q quarters after the gym opens? Okay, well, quarters, there are 4 quarters in the year, so if you wanted to convert from quarters to years, you would have to divide the quarters by 4. All right. So if you wanted t to equal, say, 1, well, you would have to, and this would be 1 year. Well, 1 year is 4 quarters. 4 quarters divided by 4. That would give you the 1. Okay. Well, this is quarters divided by 4 will give you the number of years. If it's 2 quarters divided by 4, oh, that's 0.5 years. Okay, so we want to divide the number of quarters by 4. And it looks like the only equation that does that is A. 24. For the finale of a TV show, viewers could use either social media or a text message to vote for their favorite 2 contestants. The contestants receiving more than 50% of the vote won. An estimated 10% of viewers voted, and 30% of the votes were cast on social media. Contestant 2 earned 70% of the votes cast on social media and 40% of the votes cast using a text message. Based on this information, which of the following is an accurate conclusion? All right, well, let's think about this. It doesn't matter how many voted, right? Because the person who wins is the person that, well, got the most votes of those who voted. So this 10%, I don't think that's really going to matter much. But we see that 30% of votes were cast on social media, and contestant 2 got 70% of those. So they got 30% were cast on social media. So this is contestant number 2. And of that 30%, the contestant 2 got 70%. Okay, so that would be 0.21 or 21%. So they got 21% of the vote in social media that they won was 21% of the total who voted. All right, and if you can only vote in one of two ways, if 3% voted on social media, then 70% must have voted on text message. And it says that they got 40% of the votes on text message, so that's going to be 0.28 percent, or 21% and 28% of the votes total. So they earned a total of 49% of the vote. So they did not get they did not win. So contestant 1 must have won this vote. So let's look at the answers. A, if all viewers had voted, contestant 2 would have won. No, we just said that it doesn't matter how many voted for 1, and for 2, they got 49% of the votes of the people who had voted. B, viewers voting by social media were likely to be younger than viewers voting by text message. Can't really tell that at all. That information was not given. C, if all viewers who had voted by social media instead of by text message, if all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. No, just because he won that, or he or she won more of the social media vote, doesn't necessarily mean that if more people had voted on social media, they would have if that percentage would have kept. So we say C is not the answer. And D, viewers voting by social media were more likely to prefer contestants 2 than were viewers voting by text message. Yeah, it said that they got 70% of the vote on social media, but only 40% of the vote on text message. So D is our answer. 25. Population of Greenleaf, Idaho. The table above shows the population of Greenleaf, Idaho from years 2000 and 2010. If the relationship between the population and year is linear, okay, this comes up a lot. If it's linear, which of the following functions, P, models the population of Greenleaf T years after 2000? Okay, so let's think. Okay, so we got y equals mx plus b. This comes up a lot. Rate of change is m. Starting value is b. All right. Now, the starting value is, since we're going from 2000 to 2010, starting value is 862. And 862 shows up as a constant in all of our answers. So that's not going to help us. Now we need to think about the rate of change. Well, rate of change is just change in the output, that's the population, divided by the change in the year, our input. Okay, well, change in the output is 846 minus 862, and change in the year is 2010 minus 2000. Okay, so I'm going to plug that into the calculator just to because I second guess myself. All right, so we've got negative 16 over, well, it's going to be 10. Okay, so that's going to be negative 1.6. Looks like the population is decreasing. Okay, by 1.6 per 1.6 per year. Okay? So we've got our starting value, we've got our rate of change. So let's see which one works. Well, the first one has the correct starting value and the correct rate of change. The second equation has a rate of change much greater, -16. So that's not going to work. And then the following two, well, this one looks like it could be because it has that -1.6 in it. But when you distribute that, this -2000 is going to mess with our starting value. So D is not correct. A is our answer. 26. To determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Okay. Which of the following statements must be true? Okay, so I think that's going to be a significant word here. Okay. The mean number of children per household in the community is 2.4. No. They only surveyed families at the playground. So the sample is biased. It's gonna skew towards more children. There are many households that don't have any children that would bring the mean number down. B. A determination about the mean number of children per household in the community should not be made because the sample size is too small. Well, yeah, that's one reason. It's a small sample size, but there are other reasons as well. So that might be our best answer so far, but we're going to continue. Let's see what these other ones are. The sampling method is flawed and may produce a biased estimate in the mean number of children per household in the community. Yes, that is true. Okay. D. The sampling method is not flawed. Okay, I'm going to stop right there. Definitely flawed. All right, C is our answer. 27. In the xy plane, the point PR lies on the line with the equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the same line with equation 2x plus y equals 2x plus b. If p does not equal 0, what is the value of r divided by p? Okay, so we know that if this point lies on this line, then we can substitute the y and the x with r and p. So we have r equals p plus b. Okay, and if this point lies on this line, then we know we can substitute those x and y values. In this case, we have 5r for y, and x is 2p plus b. All right, so we want to figure out what the r on p equals. Okay, well, I'm going to simplify my second equation here. I'm going to get 5r equals 4p plus b. I really think that we should be eliminating our b, okay? Because I suspect that we're going to need to isolate the r and p, and then the other side of the equation will equal some value. Okay, so to isolate the b, I'm going to subtract p from both sides. So b equals r minus p. All right, well, I can substitute that into my second equation here, and I will get 5r equals 4p plus r minus p. Okay, I'm gonna give myself some room up here. So I'm going going to combine like terms. I'm going to get 5r equals, what's going to be 3p plus r. Okay. If I can get r and p, so I'm going to subtract r from both sides. I will get 4r equals 3p. And I know I want to have p in the denominator, so I'm going to divide both sides by p. I get 4r divided by p equals 3, and divide both sides by 4. Oops. Let's get a little bit more space here. R over p, divide both sides by 4, we get 3/4. So our answer is B, 3/4. Number 28. The 22 students in a health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing a light exercise routine. The dot plots below display the results. Okay, before, we have after. Let S sub 1 and R sub 1 be the standard deviation and range, respectively, of the data before exercise, and S sub 2 and R sub 2 be the standard deviation and range, respectively, of the data after exercise. Which of the following is true? So let's compare the standard deviation. Well, the standard deviation of the first data set is clearly less, smaller than the standard deviation of the second set. The data has a very tight grouping, whereas it's very much spaced out in the second data set. So I can just say right off the bat that the standard deviations are not equal. And in fact, what else could I say? Well, yeah, okay, so I could definitely say that S is less, the standard deviation in the first is less than the standard deviation in the second. Let's keep going. Standard deviation in the first is greater? No. Standard deviation in the first is not equal to? Yeah, we could say that. Okay, so we have two possible answers so far. All right, well, now let's look at the range. The range of the first data set is going to be 88 minus 56, so that's going to be 32. The range of the second data set is going to be 112 minus 80. Okay, well, that's 2. Oh, that's also 32. So we know the range is equal on the both, so our answer must be D. 29. A photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper P remaining in the machine in minutes after the machine started printing? Okay, so key here is keyword constant rate. Constant rate. We are not dealing with an exponential equation. We are not dealing with either of these. So we want to think about our friendly equation, y equals mx plus b. Okay. Well, we got our b, our starting value. Both of our equations have that. So we're just trying to find the rate of change. So after 20 minutes, it has used 30% of the paper. Well, what is 30% of 5,000? Well, it's 5,000 times 0.3, or better yet, 5,000 times 3/10. Okay, well, that's going to be, we can divide top and the bottom by 10. We'll get 3 over 10, or 3 over 1. And then 3 times 500 is 1,500. So if it uses 1,500 sheets in 20 minutes, what is the rate of change? Well, that's, again, M is 1,500 sheets in 20 minutes. Well, that's going to be 75. So it uses 75 sheets per minute. Okay, so our answer is B. 30. The complete graph of the function f and table of values of the function g are shown above. The maximum value of f is k. What is the value of g of k? Maximum value of f is k. Okay, well that's 3. What is g of 3? Well, g of 3 is you have an input of 3 into g, and you get out a 6. All right. 31. There are 2 atoms of hydrogen and 1 atom of oxygen in 1 molecule of water. How many atoms of hydrogen are there in 51 molecules of water? Well, there are how many atoms of hydrogen? So there are 2 atoms of hydrogen in 1 molecule of water. There are 2 per 1 molecule of water, and we know we have 51 molecules of water, therefore we're going to have 102 atoms of hydrogen. 32. If x equals 1 in the equation above, what is the value of a? Alright, so we just have a direct substitution. We're just going to put in 1 for x, 1/2 a equals 0. I'm going to add 1/2 a to both sides. Okay, well, to undo this 1/2, I just need to multiply by the reciprocal, which is 2 on both sides. So I get 2 equals a. 33. If the in the xy plane, the equation x plus 2y equals 10 and 3x plus 6y equals c represent the same line for some constant c. What is the value of c? Okay. Represent the same line. Okay, for some value of c. Okay, so we just need to get these in the same form. So if the left side of both equations was the same, right now the left sides are not the same, so the constants are not the same. But 3x plus 6y equals c. I can see that if I multiply this first equation by 3, well, then I would get 3x plus 6y equals 30. Okay, well, 30, so the left sides are now the same, therefore c must be 30. 34. On April 18, 1775, Paul Revere set off on his midnight ride from Charlestown to Lexington. If he had ridden straight to Lexington without stopping, he would have traveled 11 miles in 26 minutes. In such a ride, what would the average speed of his horse have been to the nearest tenth of a mile per hour? They underline that because they set this up where it's in miles per minutes, and then we need to convert that into hours. So we have 11 miles in 26 minutes. So let's see, and we want to know how many miles, 11 miles in 26 minutes. We want to know how many miles in 60 minutes. Okay, so we have a proportion to solve here. We cross multiply and we'll get 666 660 equals 26x divided by 26 divided by 26. So I'm just going to do that on the calculator. So I have 660 divided by 26. I get 25.384. But we're rounding this to the nearest tenth, and that would be 25.4 miles per hour. 35. The graph of the function f defined by f of x equals negative 1/2 quantity x minus 4 squared plus 10 is shown in the xy plane above. If the function g, not shown, is defined by g of x equals negative x plus 10, what is one possible value of a such that f of a equals f of g? Okay, so we just want to know, we want to know where the functions are equal. So that's going to be, let's get this. It's going to be negative 1/2 x minus 4 squared plus 10 equals negative x plus 10. Okay. So what I'm going to do here is I'm going to subtract 10 from both sides. It's going to cancel those out. And then I will multiply both sides by negative 2, and I'll get x minus 4 squared equals 2x. Alright, so I'll expand the left and get x squared minus, that's going to be minus 8x plus 16 equals 2x. And then subtract 2x from both sides. I get x squared minus 10x plus 16 equals 0. Okay, so from this point, it's pretty easy to factor this. My a is 1, so I'm looking for two numbers that multiply to c and add to b. Okay, well that's going to be, in this case, it looks like it's going to be negative 8 and negative 8 and negative 2. Alright, two negatives multiply to a positive, add to a negative. Alright, so we have an x solution of positive 8, and we have a solution of positive 2. Either one of those values will work. Number 36. In the triangle RST above, point W, not shown, lies on RT. What is the value of cosine angle RSW minus sine angle WST? Okay, so let's set this up. Got a point somewhere here on RT, and we have an RSW. Well, RSW is going to be RSW, that's going to be that angle. And we have another angle, WST, what's going to be that angle? Well, we can see that these two angles add up to RSW plus angle WST equal 90 degrees, so they're complementary. And we can see that if we do a little sketch here, if this is A, B, and C, that'd be lower A, lower B, and lower C. Sine of B is going to be opposite over hypotenuse, which is going to be B over C. And cosine of A is going to be adjacent over hypotenuse, which is B over C. And we know that A and B are complementary. Therefore, the sine of and cosine of complementary angles are going to be equal. So what we're doing here is we're taking these. This is going to equal, let's say x. Well, sine of its complement is also going to equal x. So if you subtract x from x, Your answer is 0. All right, 37 and 38. We have a table and we have a graph. When a patient receives a penicillin injection, the kidneys begin removing the penicillin from the body. The table and graph above show the penicillin concentration in a patient's bloodstream at 5-minute intervals for the 20 minutes immediately following a one-time penicillin injection. All right, so on the next slides, I'll bring these back up. So, okay, 37. According to the table, how many more micrograms of penicillin are present in 10 milliliters of blood drawn from the patient 5 minutes after injection than are present in 8 milliliters of blood drawn 10 minutes after injection? Well, 5 minutes after injection, there are, get a pen, 5 minutes after injection, there are 152 micrograms per milliliter. And if you have 10 milliliters, well, then there will be at we'll call it A, the first case, there will be 10 milliliters times 152 micrograms per milliliter. That's going to be a total of 1,520 micrograms. Now at 10 minutes, we have this is B. 10 minutes, we have 8 milliliters, but the concentration at 10 minutes is 118. 118. Okay, so that's going to be 8 times 118. 4, carry the 6, it's going to be 14, carry the 1, 9. 9, 4, 4. Okay, and we want to know how much more there are at the 5-minute interval in 10 milliliters. Well, that's going to be 1,520 minus 9, 4, 4. Okay, so we have, it's going to be 14, it's going to be 11, and that's going to be 10, 6, 7, and 5. So we have 576 more micrograms. 38. The penicillin concentration in micrograms per milliliter in a patient's bloodstream T minutes after the penicillin injection is modeled by the function p, defined by p of t equals 200b raised to the t on 5. If p approximates the values in the table to within 10 micrograms per milliliter, what is the value of b rounded to the nearest tenth? Okay, so all right, so let's see. Let's take some input and outputs here. So if we, I'm gonna take the first I'm gonna take this guy right here. So 5. This point. This is a data point. 5, 125 or 152. And I know that the output then is 152 when the input is 5, or that would be 5 over 5, which is 1. Okay, well then b, which is b to the 1 is just b. So I'm going to divide both sides by 200. And I will get that b equals 152 divided by 200, 0.76 equals b. Okay. Now, if we're rounding to the nearest tenth, right, that's actually going to be, I want to bump that up to 0.8 or 8 tenths.